Hello everyone. In today's session we are going to design a DC to DC buck converter. This is the simple schematic and which will be very useful to the student who want to learn about how to use the KiCAD. In this particular session we are going to design this entire schematic. We will add the individual symbols to our KiCAD software. We will also learn that how to select a particular footprint, how to route all the components, how to write the names, and how you can add your custom logo to the PCB. We will also add some 3D models. So this is the PCB that we are going to create in today's session. We will also learn how to order this PCB from the JLC PCB. So now to create this project, first close all the previous windows and let's create a new project. So go to the file, click on the new project. It will create a new project. Give the direction where you want to create your project. So I am creating on the desktop and give the name as an DC-DC converter, that is for the C. I will copy the name, go to the folder and paste the name here, which will be the same for the project also. Now click on the save button. It will create a schematic as well as the PCB. So first we are going to create a schematic page in which we are going to add all the different symbols. So first let us go see our schematic again so that we will have a better idea. See this, in this schematic we need a two SAM connector, one capacitor, one IC which will be the buck IC, one inductor, one capacitor and two resistors. Okay, so first we will look forward for the three different components, that is two connectors, one IC and the inductor. So here I have all the data sheet which we need. Okay, so in this particular data sheet I am using the connector which is 2828, which is given here 2828342. Okay, so how to add the particular symbol to our library? Currently I have added all the symbols, but we will learn that how to add all the libraries in our KiCAD. So first go to the datasheet, copy the name of our part number and open the library loader. If you don't know how to add the or how to create the schematic symbol and the footprint symbol, then you can find the links below in the description. Okay, now click on the search for parts. It will open the Mouser site. You have to log in this particular site, so please sign up for the same. I have currently login in this particular site. Okay, now paste your part number here and click on the search. It will find the part for you which is mentioned in the datasheet. So see here we have connector that we want. This shows that this connector has a KiCAD model and the 3D model, and this is the datasheet. Okay, so how we can download this particular footprint and the symbol and 3D model? By just clicking here and click here on the free downloads. It will download the library. Okay, and see this, it will show after downloading the library loader will shows that the part is already exist in our library, because in the past I had added this symbol. Okay, so I will just overwrite it and say yes. It will overwrite entire symbol. Okay, now what will be the second part? Okay, second part is this IC, that is TPS 561208 DDCR. Okay, so second sheet is this TPS, which is a synchronous step down voltage regulator in 6 pin. Okay, and it has a package of SOT23, and this is the basic schematic, simplified schematic given in the datasheet. Okay, so what I will do, I will just copy this part name, go to the Mouser site and paste here. It will search the part name. See here, all the components are same, almost same. There is no change in the schematic as well as on the footprint. Let us see one by one. First we will look forward for the symbol, ground SWV in, VBST, EN, VFB. Same here in this case, same here in this case, and same here in this case. Okay, so almost everything is common. So we will select one of the component out of 4. Okay, so let us select this third one, click on the component and click on the free download. It will download the file and it will say the part has been added to this MXS part. Press OK. Now we need this inductor. See this in our schematic we have one inductor which is a 4.7 microhenry inductor. 4.7 microhenry inductor. So I am using this SPM series inductor. So this is the datasheet for the SPM series inductor, and I will use 4.7 microhenry. 4.7 microhenry inductor, and the part number of this inductor will be this. Okay, so Mouser is providing very good platform. You can just copy and paste your part number. It will search a footprint for you. Okay, so same, paste and click on the search. It will search part for you. See this. This is the same inductor which is available in the KiCAD. Okay, project is closed. So go back to this particular project and download this KiCAD model. Click on the free download. It will download the part and it will give the notification that part is already exist. So click on the yes. Okay, if you are downloading it first time, it will not showing this overwriting option. Okay, now go to the schematic. Okay, this is the schematic. Shift to the second screen, and this is my recorder. Okay, everything is okay, and this is the COM. We don't need this. Okay, everything should be closed. Okay, now to add the schematic symbol, click on this add button, or you can press the A button in the keyboard. Okay, or click on the icon. Now first we will add the connector which is 2828342. Okay, and it is added in this MXS library. So double click on it, and this is our part. Okay, so how to add the component? Click on the button, search for the part, double click on this particular part you want and add in the blank space. Okay, click cancel to cancel the command. Okay, now we want this pin on the right side. So what we will have to do, just right click on it and mirror horizontally. Okay, so this is our first connector is added. Now we want this capacitor and this ground. Okay, so to add the capacitor, click on the add symbol, type C small. I want small capacitor symbol, so it will use less space, and put anywhere by just clicking on the blank screen. Okay, it will be ready, and the capacitor rating will be 22 microfarad. So click on the C small, which is the value field, and I will add the 22 microfarad capacitor. Okay, now this is the position. To add the ground, what we will do, we will click on this ground and search for the ground, G and D. You can choose any one of you want. Currently we are using this ground. Okay, just click on anywhere, and to connect this component we will use this wire. So click on the wire, you can connect this component. You can cancel this command by just right clicking and cancel. If you want to use shortcut, then you can press W. It will automatically start wiring. And in this particular KiCAD 6 version, if you will hover the mouse here on the point, it will show this green plus sign and line sign. You can automatically connect with the net simply. Okay, now what we want in the second page. Okay, so this capacitor is added and this ground is added. Now we want to add this ground. Okay, so just click on it, Control C, Control V, paste, connect. Okay, now we want this IC TPS 5612. Okay, so click on the add button. It will open the library, and we want type TPS 5612. Okay, see this, both are the same. So click on any one of the component and add to the schematic page. Okay, so our IC is added. Now we want to connect all the connection. Okay, see this, instead of net we can use labels, or we can also use net names. Okay, so I will explain everything so that you will have better idea that how to use the net names and how to use the labels. Okay, now we want to connect this line with the pin number 3. So first I want this pin to the top side, so I will move it vertically. It will vertically move the entire symbol and it will be the mirror one. Okay, now to join this connection, I will start from here and I will extend this line. I will click on the symbol, press M on the keyboard, and it will automatically move the part. Okay, click where you want. Now this particular pin number 3 is connected. I want to connect ground here, so just copy, paste and connect it. Okay, now what we want that our SW and the VBST should be connected. So instead of using this net, this green net from 2 to 6, we can use labels to cleanly design the schematic. Okay, so I will use the label, and label is here. Add a global label, or you can press Ctrl L from the keyboard. Okay, so I will give a common name to these two pins. Okay, so I will give the name as a VBST. Everything should be same, VBST, and okay. So simply click here and press the W. It will run the command from the wire. You can Ctrl C and Ctrl V. Best habit to copy and paste the labels, otherwise there will be a mistake. Okay, so now our pin number 2 and pin number 6 is virtually connected. We can also use the net labels. We want this EN, which should be connected with this input. Okay, I will consider this one as a positive input, and this will be our input connector. Okay, so let us rename this as an input. Yes, so we can connect this particular pin by using simple wire, but if you want to create a simple schematic, then what we can use the net name. Similar to this global, this tag, okay, this global label, we can also use the net name locally. Okay, so simply click on this net and write the name as an in, and click here anywhere on the net. It will give this name to this wire. Okay, and two similar net name wires will be connected with each other. Okay, so here I am writing this name. See this. This is the in. This is the in, means two wires are virtually connected. But this is the global tag. If you are using the hierarchical sheets in this KiCAD, then it will be perfect. But sometimes these net names are not working into different hierarchical sheets. Okay, so I wish you will take care when you are creating a complex project in the future. Okay, now we want to add two resistors. So click on the add symbol and type R small, because I want a small value of resistors and I will use US standard. Okay, and here I will place the resistor, and the resistor value will be 10K. Okay, and press OK. Just copy and paste the resistor and change the value to 56.2K. Okay, now these two part, okay, alignment should be perfect. So just click on this resistor and press M. It will move, and select all the part and move. I will use wire and connect it to the resistor. This is the voltage divider. Okay, and this should be connected with the ground. So Ctrl C, Ctrl V, put here and connect it via bus. Sorry, wire. Okay, now what we want one inductor. See this, one inductor, one capacitor, which will be connected to this VBST global tag. Okay, so I will add a inductor, and inductor, the name of the inductor is SPM3015. Simply. Okay, and now I will add it here and join inductor and the resistor by using the wire. Now we want one capacitor, and again write the C small. From recent you can use directly the capacitor value. Okay, and it is connected in the series. Press W, connect the net and extend the wire. The value of C is 0.1 microfarad. Okay, press enter, and this wire is connected to this VBSD. So simply copy, paste and place. Okay, so this is our schematic. Now we want the same connector in the output side. See this same connector, one is grounded. Okay, so copy, paste the connector and right click on the connector and mirror horizontally. Okay, and put this here, and we want this net should be connected with this connector. Click on the connector to move, click on the wire, click here and Control C, Control V. Our connector is ready and our schematic is also ready. Now we want to give the numbers to all the components. So now click on this designator and click to annotate the schematic. So after annotating, all the symbols are annotated successfully, and this is our schematic. Now we will go forward for the footprint. So to add the footprint, we will use this run footprint assignment tool. Click here on the yes, and we want to select the footprint by means of a description and the number of pins. If you want to add the library custom lead, then you have to just select this L. If you want to use the internal libraries, then you have to select these 2 points. Okay, so I am currently utilizing this internal libraries, so the particular description and the pin number are selected. This is the capacitor C1 and C2. I will use the package 1210 SMD package. So I will select it from here. This is the 1210 package, which is metric. Click on the right click on the footprint. It will open the footprint and it will also open the 3D models. Okay, so this is the 3D model for this particular capacitor, and this is the footprint. Okay, so I will select this footprint for these 2 capacitors. So double click, and these are 2 resistors. I will use same package, that is 1210. Okay, 1210, and add it to the library. If you want to see the footprint, then right click here, and if you want to measure the dimension, simply you can use this scale tool and you can measure the dimension of the resistors. Okay, so just for the precautions, we have to verify the footprint. Now all the footprints are added. These are the schematic part libraries, which is automatically added to this library. If you want to add the custom link, then what you have to do, you just have to select this library option. Okay, for example, if we want to add this 282834 by manual method, so you just have to select this library. You want to add this footprint, so click on this and search for your SemAxis library. Okay, so this is the SemAxis part library, and we want a 2828 series connector. Okay, so you have to manually scroll all the connectors, and somewhere you will find this connector that we want to add. Okay, where is the 2828? Yes, it is here. Just right click on this connector and see this. This is our connector that we want to add. Okay, so simply double click on this part. It will add it to this particular schematic symbol, and press OK. Save the schematic, and our schematic is now ready. To create a footprint, what we have to do, we have to click in this open PCB in board editor. It will create, or it will open the PCB file. So our PCB file is open, but here we does not have any component. So to add the components, we have to go to we have to click on this particular update PCB with changes, and click here on the update PCB. It will add all the parts here in our schematic. So see this, these are our components that we have selected from the footprint selections library. Okay, so I will rearrange all the components, and then we will go for the routing. If you want to move the symbol, then just click on the symbol and press M on your keyboard. If you want to rotate, then simply press R on your keyboard. Okay, so this is our two footprints. One is for the input and one is for the output. See this. Here IN is showing, the value name is IN, net name is IN. So we can easily recognize that this is our input pin. If we will not giving this net name, and if you will connect this net directly by using wire, then we cannot recognize the input pin. See this, it will give some random name by using the KiCAD libraries or KiCAD functions. Okay, so it is good habit to give the net names in the schematic. So Control Z, Control Z, Control S, go to the PCB and update the PCB. So it will add the net name again. Okay, so it is a good idea to add the net name in your PCBs. Now these two connectors are arranged. Now we want add capacitor. So it will be the perfect position here. Now we will add the largest part, which will be the aligned with the input. Okay, perfect. And now we will select the R2, and R2 will be perfect here. Okay, and let us select the R1. R1 here is in the series, and this is the inductor. Okay, see this, we cannot recognize the which is the out one, which is the ground. So we can simply give the net name to our schematic. For example, this net name is for the out. See this, in this particular connector there is a two complex name. Okay, now after adding the net name, for example out, we can easily recognize the input and output terminals. Okay, simply go to the PCB and update the PCB, update. See this, this is the our output positive terminal. Okay, and here in the schematic this is the ground. So this is the random name. If you will define the net name here, for example ground, GND, it will be perfect. Okay, so we can easily recognize all the terminals in the complex schematic also. Okay, update, update, and close. Okay, now what we want to do, we will just arrange all the components, and I think in should be on the top side, so it will be the better way. Okay, perfect, and this will be the out. Okay, and it should be rotated by 90 degree, and this is the capacitor. Okay, so it will be at the perfect position. Okay, I will just place it here. I think it is here perfectly, and here perfect. Just move little bit. Okay, so all the footprints are relocated perfectly. Now if you want to rearrange the silkscreen, so just click on the silkscreen reference, press M to move, and before that just hide this fabrication layer. Okay, and click on the silkscreen and move the component name values. Click on this L1, because after routing component will be moved, so you have to arrange all the silkscreen again, or you have to take care while you are moving the silkscreen. In this particular case, if there will be a movement in the symbol, then there will be no issue with disconnection of the nets. Okay, so click on this R1, rotate, move, place. Click on the C1, move and place. Okay, so all the component names are proper. Now if you want to define the plus and minus sign and input and output sign, then you just have to use this text box. You can define the input, okay, and you can place anywhere you want. For example, we want to place it here, we can move this capacitor, and you can use out here. Okay, we can move this inductor. Okay, now if you want to align both the text vertically, then you have to click on the first, press shift, click on the in, right click, align and distribute, and align to horizontal center. It will vertically align both the component. And see this, there's two connectors are not aligned, so you just have to click on the first connector, press shift, hold it, and click on the second connector, right click on the one of the connector, click right click and align, distribute, and align to horizontal center. It will align automatically. Okay, now if you want to add the plus and minus sign in the connector, so again you have to use the text box. And see this, here we have a red layer. Red layer means a front copper layer, so this will be added in the copper, but we want to add it on the front silkscreen layer. So click on the in and change the layer to the front silkscreen. Okay, front silkscreen, both are added to the front silkscreen. Click on the text to add the plus and minus sign. So this will be the in, will be the plus, so plus, simply Control C, Control V, and plus. Okay, now if you want to add the minus sign, so simply write minus, press OK, and just copy and paste. It will be here. Okay, if you want to align this sign also, then simply select all the names and right click and align, distribute horizontally. Okay, everything is aligned properly. Now to route all the components, we can create a different net classes for different sizes. For example, if you want a 0.5 mm track or 1 mm track or 2 mm track, so just go to this track and you can define a different track width here. For example, we want a 0.5 mm track, 1 mm track, and then 1.5 mm track. Okay, you can also define the via sizes here. So first let us see one of the net. It will take some time to update the net. Okay, 0.5 mm, 1 mm, and 2 mm. Okay, let us add 1.5 mm also and press OK. Our net values are added here. For example, if you want to add a 0.5 mm track, then just click here on the track and select the 0.5 mm. Click here on the route tracks and click here anywhere you want to route. See this is our 0.5 mm track. If you want to change the track width, for example 1.5 mm, then simply click here on the track and click. So it will change the track width. If you want that each and every time you have to select the different size of tracks, and it is a tedious process, so what you have to do, you have to just click here anywhere on the pad and you have to hold it and press Q on your keyboard, and it will open a new window and it will ask for the size of the track, via, and the drill. For example, we want a 1 mm track, then simply type 1 and press OK. It will change to the 1 mm. If you want to use a different size, then press Q, write 0.5 mm, press OK. It will be the 0.5 mm track. Okay, so I will be using this 0.5 mm track to route. So simply click and click. Okay, so routing is a fairly simple process in the KiCAD, and I will route for the single layer. For now, I will guide you to how to add the wires also. Now see this, in this particular case, if you want to move this track without removing it, you can just click on the track and press D on the keyboard. It will drag the track. Okay, for example, here if you want to move this particular part, particular wire to the left side, then simply click on the wire and click D. It will move the wire. Okay, simply again go to the net, select the net and ground. Same for this. Okay. 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 Same for the this, and this will be the ground. Okay, if you want to move this particular part, you can simply press D, it will move the wire. Okay, now see this, there is no way to route this wire to this VBST. Okay, we can move like this, and we will make a loop to connect both the VBST, but we can also use via to add. Okay, so to add the via, just click on the any track, press V on the keyboard, it will select the via, click on the PCB to put the via, and it will automatically change the layer. Okay, again if you want to move to the front copper layer, which is the red one, so again click press the V on the keyboard, it will again select the via, place via anywhere you want and track. Okay, so this is how you can add the via. For example, again if you want to practice, then click on the wire, press V, it will select the via, click, it will put the via on the PCB, again press V, it will select the via and click on the PCB, so it will put on the via on the PCB and it will change the layer. Okay, so this is how you can use the track and via in the different layer. Okay, so this is our routing. Close the front fabrication layer, and now we want is a border, edge cuts. So we will add a small border from which our PCB will be cut. Okay, so this is our border. Now if you want to inspect our PCB, then we have to go to the view and 3D viewer. It will give the 3D model. Okay, so this is our PCB that we have created in today's session. Now if you want to add the text, then you can just simply add amazing automation. Okay, and simply change the layer to front silkscreen. Okay, now go to the view and 3D viewer. See this, our name is available here on the front silkscreen. If you want to add the same silkscreen on the back side, then what you have to do, you just have to copy and paste this name, Ctrl C, Ctrl V, it will copy and paste our name. And what you have to do, you just have to select and press E on your keyboard, and you have to move it to the bottom cell screen. Okay, it will move to the bottom cell screen. Now go to the view and 3D viewer. This is our front cell screen, amazing automation, and this is our back bottom side cell screen. Okay, and now see this, our cell screen is mirrored, so we have to mirror it again by just clicking here and bottom cell screen, press E on your keyboard, and you just have to click here on the mirror and press OK. Okay, now go to the view and 3D viewer. Our amazing automation is perfect on the front and amazing automation perfect on the back. This is our via and this is our through-hole components. These are our assembly components. Okay, now if you want to add your custom logo in this particular PCB, then what you have to do, you just have to go to the main window of the KiCAD, go to the image converter, it will open this type of window, and you have to load the bitmap image. Okay, so this is our desktop, and here I am using this amazing automation logo. So double click on this logo, it will open here, and we have to give the size. So first let us measure the size of our logo in our PCB. I will put my logo on the back side here. So I have lots of space, but before that let us measure the space. So I will use this space, which is almost 8 mm by 8 mm is perfect. Okay, so I will go to the image converter and give the size here 8 mm by 8 mm. Okay, 8 mm by 8 mm. Now I want my logo as a footprint, and I want to put this logo on the silk screen. Okay, so I will use this as a front silk screen. You can also change the layer also. Okay, now simply export to the file, and I will use this logo pretty library. Okay, or if you want to create a custom library on your project directory, then simply create a new folder which is logo library, and you have to give the extension which is pretty. Okay, sorry, pretty. Okay, perfect. You have to open this and save here. Give the name as a logo and save here. Okay, close this window. Now you have to add the library, logo library, to this particular project. So for that, what you have to do is that go to the main window, click on the preference, manage footprint libraries, click on the project specific libraries, click on the folder and go for this folder. Double click on this folder and select the folder, press OK. Okay, now our library is added. Now you have to add this logo in this footprint PCB. So you have to click on this footprint, click on the footprint and go for the logo. See this, our logo is now available with perfect size. Okay, and let us see what is there. See this, there is a something else which is a G star star star. So first we will remove this particular G star star by just double clicking on it and check this visible out. Okay, now let us see what is there. Go to view, and this is our logo. We want this logo on the back side, so simply just double click on it and change the side from front to back. It will move to the back side and it will change its color. So go to view and 3D viewer. Okay, so see this is your logo. Now if you want to rotate this logo, then simply click on this logo and press R. You can move this logo anywhere you want and simply go to the 3D viewer. See this, our logo is rotated. Okay, again if you will rotate the logo, go to the 3D viewer, it will automatically refresh your 3D model. Okay, if you will move the part from the footprint editor, footprint or PCB, and you can, if you will reroute all the entire PCB, and if you will go to the part, see this, it will move the 3D part automatically. Okay, so this is the today's session in which we had learned about how to create a schematic, how to add the schematic symbol, how to select the footprint symbol from the footprint libraries. We have routed entire schematic and add our custom logo to our PCB. Okay, so this is the end of our today's session. We will meet soon in the next session.